let's look at an example. If f of x is equal to 1/10 x to the 5th minus 1/2 x to the 4th plus 10x minus 7, find where f of x is concave or convex and locate any points of inflection. So we're going to do this just by calculating the second derivative. And if f double prime of x is greater than 0, then that's where it will be concave. If f double prime of x is less than 0, that will be when it's convex. And then if f double prime of x is equal to 0 or does not exist, then it might have a point of inflection. And so we're going to do all of this with a sign test. So in order to find the second derivative of f, you first have to find the first derivative of f. So here I can just use the power rule. So I have 1/10. The derivative of x to the 5th would be 5x to the 4th. And then I have a negative 1/2. Derivative of x to the 4th would be 4x cubed. And then the derivative of 10x is 10, and derivative of negative 7 is 0. 1/10 times 5 would be 5 over 10. That reduces to 1/2. 1/2 times 4 is a 2, so that would be negative 2x cubed plus 10. Now that I have the first derivative, I can take the derivative again, and that will give me the second derivative. Derivative of 1/2 x to the 4th is 1/2 times 4 x cubed. Derivative of 2x cubed would be 2 times 3x squared. And then the derivative of a 10 is 0. 1/2 times 4 is equal to 2, so 2x cubed. Negative 2 times 3 is negative 6, and then x squared. So that is my second derivative. What we do now is we want to find when is this positive or negative. So we need to set this equal to 0, and then solve for x. So in order to solve this, I'm going to factor and set each factor equal to 0. So the greatest common factor between 2x cubed and negative 6x squared, well, let's see, they're both divisible by 2. And then if I look at the variables of x, the lowest exponent is 2, x squared. So they both have an x squared common. So after I factor out 2x squared, I'm left with x minus 3. So now I can set both of these equal to 0 separately, and then solve each one for x. So that gives me two critical values, x equals 0 and x equals 3. I also want to consider when does f double prime of x fail. So my second derivative I calculated right over here, and that was 2x cubed minus 6x squared. Since I'm not dividing by x anywhere, that means that the second derivative does not fail. So next up, we want to do a sign test. To do a sign test, you want to draw a number line. And then all the critical values that we found, plot those on the number line. So we only have two critical values, x equals 0 and x equals 3. So I'm going to put 0 over here, 3 over here. On the bottom, I'm listing values of x. And then above the number line, I want to list attributes of f double prime of x. So over here, we found that whenever x was equal to 0 or x equals 3, that f double prime of x was equal to 0. So I'm going to put a 0 above the 0, and I'll put a 0 above the 3. Now we need to create new points around each of these critical points. So to the left of 0, I'll choose negative 1. Between 0 and 3, I'm going to choose 1. And then to the right of 3, I'll choose 4. Each of these critical points gets plugged in to the second derivative formula. That'll tell me if it's positive or negative at that point. So my second derivative was 2x cubed minus 6x squared Negative 1 cubed is negative 1. 2 times negative 1 is negative 2. Negative 1 squared is positive 1. Negative 6 times positive 1 is negative 6. Negative 2 minus 6 is negative 8. So here we really only care about the sign of your answer. Negative 8 means it's negative, and so I just want to put the negative sign above the negative 1. So now we can do the same thing with that second new point of 1. So I want to do f double prime of 1, and I'm just plugging 1 into that second derivative formula. 1 cubed is 1, 2 times 1 is 2. 1 squared is 1, negative 6 times 1 is negative 6, and then 2 minus 6 is equal to negative 4. So since I have a negative answer, I'll just put a negative sign above the 1. And then finally, I'll use x is equal to 4 and plug in 4 for the x's inside of f double prime. So 4 cubed is equal to 64. 64 times 2 is 128. 4 squared is 16. 6 times 16 is 96. 128 minus 96 is equal to 32. So that is a positive answer. So I will put a plus sign above the 4. So let's think about what all this means. We know that f double prime is negative here, and it's negative here, and it's positive here. So anywhere that f double prime is negative, that's going to be where it's convex. So it's convex here, and it's convex here. And then anywhere that f double prime is positive, that's going to be when it's concave. So it's concave right here at 4. Then you have a point of inflection whenever your second derivative is 0 or does not exist, and it changes sign. F double prime changes sign around it. So right here at x equals 0, we have a 0 second derivative, but notice f double prime does not change around it. It's negative to the left, it's negative to the right. That means that there is not a point of inflection at x equals 0. At x equals 3, we have a 0 for the second derivative. If you look to the left, it's negative. If you look to the right, it's positive. So concavity does change around x equals 3. That means that there is a point of inflection at x equals 3. So I know the x-coordinate for the point of inflection is 3. And if you plug 3 into f of x, so that would be f of 3, that would give you the point 3, 6.8. So I'm just rounding that to one decimal place in this case. When we tested points, we only found one point where it was positive. But this is actually going to be positive everywhere to the right of 3. So since there is no other point to the right of 4 where we have a 0 or does not exist for the second derivative, that means that the concavity could not change anywhere else to the right of 3. So since this is concave at 4, it's going to be concave everywhere to the right of 3. So the interval for concave would be 3, infinity. So our interval for convex would go from negative infinity all the way up to 0, and then also from 0 all the way up to 3. So we have negative infinity, 0, and then we can use u, that stands for union, and that would go from 0 to 3. Here's our graph of f of x, the same f of x we were just using. Let's look to see if these exact points that we found analytically align with what it looks like the graph is doing. So first, let's look at concave. We found that this was concave from 3 to infinity, and if we inspect the graph, that does look to be true. So the x value of 3 is right here. So if we look up from there to the right of 3, it is concave. So it's curving upwards in that space. We've found that it's convex from negative infinity to 0 and also from 0 to 3. So the graph of f of x was so big that I wasn't able to fully capture what happens down here at 0. But if you were to graph this inside Desmos, you would see that it basically just straightens out into a straight line at 0, and then after that, it's convex again. And finally, our point of inflection, we found that to be 3, 6.8. So 3, 6.8 would be right in here. And that does look to be true. This does look like it's about 6.8.